We have a 5 kilogram box is lifted vertically with a force of 60 newtons over a distance of 3 meters. Calculate the work done by the applied force and the change in gravitational potential energy of that box. So we have some box, I'm assuming it's attached to a string, and the box is going to be lifted vertically with a force of 60 newtons. So the mass is 5 kilograms. The force is 60 newtons, and our change in position is going to be 3 meters. This means that we can consider the initial position to be 0 and the final position to be 3. And we want to find the work done by the applied force, and we also want to find a change in potential energy. So this is going to be work. We know that work is force times, let's call it the change in position, cosine of theta, where this theta is the angle between the force and the change in position. We also know that work is equal to a negative change in potential energy. And we have potential energy due to gravity is mgh. So the first thing that it wants us to find is it wants us to find the work. So work is equal to force times our change in position, cosine of theta. Since the force is going to be going in the positive up direction, and our box is also going to be moving in the positive up direction, the angle between these two is 0, meaning that cosine of 0 is 1. So our work is just going to be the force times our change in position, meaning that the work will be 60 newtons times 3 meters, and we get a work of 180 joules. So this is our answer to the first part. The next thing it wants us to consider, I'll do it over on this side. The next thing that it wants us to consider is our change in potential energy. So our change in potential energy is going to be equal to the potential energy of the final position, meaning the potential energy at y final, minus our potential energy at y initial. Because y initial is 0, this term is going to go away. So our total change in potential energy is going to be mg y final, where we have a mass that is 5 kilograms, g is 9.81, and y final is going to be 3 meters. So our change in potential energy is going to be 147 joules. Now we know that from our conservation of energy that work should be equal to a negative change in potential energy. But this is assuming that there is no additional work that has to be applied. So if we think about this, we now have a situation where our work is not equal to the change in potential energy, right? We have two very different values here. We have, more specifically, a 33 joule difference between the two. This difference could be due to things such as resistance. It could be due to trying to accelerate the object. And it could be compensating for other forces such as friction. So this means that this 33 joules has been lost to something such as friction. So in what situations would we want to use work is equal to F times some change in position cosine theta versus work is equal to a negative change in potential energy? Well, if the only force that we have is gravitational potential energy, or in some cases spring potential energy, we would want to use this term. But because we have an applied force acting on the object, we need to use the other definition of work. So this work is equal to a negative change in potential energy is only valid when we only have gravitational force causing this change in the potential energy, or spring force causing this change in potential energy.